Welcome to Logics. The previous class we have discussed about the keywords, what are the different types of keywords, we have seen them, and in this today's class I'm gonna give you an overview related to the Verilog data types. Okay, this is the first video that is related to the Verilog data types. The primary intent of data types in the Verilog language is to represent data storage element. It's going to be highlighted data storage element like bits a flip-flop, and this is the one of the main reason, and also transmission elements like wires that connect between logic gates and sequential structures. The main primary intent to have a well data types, what type of data type that we have in our main motive is to have a storage element data type and also as well as transmission element data type like void. What values can do variable hold? Almost all data types can only have one of the four different values as shown in below except for real and event data types. For real and event data types, remaining all data types will have these particular four values we can store in those data types. Okay, yeah, except for real and event. The first value that we can able to store is 0, which represents a logic 0 or a false condition, where the second is 1, which represents a logic 1 or true condition. X represents an unknown logic value, can either be 0 or 1. Z represents high impedance state, or simply we can able to say that it is a no connection or open state, open source, open circuit state, where we gonna use green for 0 and 1 representation in the simulation graphs. Most of the simulators use the convention where red stands for don't don't care, it's the X value, and also orange in the middle stands for high impedance or Z. Okay, what does the Verilog value imply? Since Verilog is essentially used to describe hardware elements like flip-flop and combinational logic like NAND and NOR. It has to model the value system found in hardware, isn't it? Verilog is essentially used to describe hardware elements like flip-flops and combinational logic circuits, NAND and NOR. So we have to, it has to model system value found, right? So this is the thing. A logic 1 would represent the voltage supply VDD. Logic 1 represents 1. 1 means what? Means it represents the voltage supply VDD, which can range from zero point 0.8 volts to more than 3 volts based on the fabrication technology node. Okay. Similarly, logic 0 would represent ground and hence a value of 0 volts. X or X means that value simply unknown at the time, can be either 0 or 1. This is quite different from the X that is treated in Boolean logic, where it means don't care. Okay, it's not similar to the don't care in Boolean algebra. X means can either be 0 or 1 at, at any time. Okay, as with any incomplete electric circuit, as with any incomplete electric circuit, the wire that is not connected to anything will have a high impedance. For air, we have the high impedance, or we can able to see the infinite impedance, right? High impedance, it is at that node and is represented by Z or small z. Even in Verilog, any unconnected wire will result in a high impedance. High impedance means it's nothing but simply an open circuit or unconnected circuit or half connected circuit. We can able to represent like this. So I'm gonna repeat again. A logic one is nothing but the voltage levels that represents VDD. The VDD lies from 0.8 volts to more than 3 volts, whereas logic 0 represents the ground or the uh, 0 volts, and whereas X represents the simply represents nothing. We can be either 0 or 1, whereas high impedance is nothing but the unconnected or open circuited circuit. So this is all about this video. Let us meet again in the next video.